been built.
But all of this creative thinking still didn't solve the fundamental challenge of constructing such an expansive dome with no internal support. Brunelleschi would still need to figure out how to prevent it from collapsing. It would demand his greatest leap of imagination yet, combined with a lot of hardcore calculation. Brunelleschi was granted the first modern patent for his invention of a river transport vessel. (1420), Florence, Italy. The visionary architect and engineer, Filippo Brunelleschi, has been commissioned to construct the most magnificent dome in the world, the cupola at Santa Maria del Fiore. But first, he will need to prevent it from crumbling to the ground without supports.
Now, it's one thing to invent a clutch and a flywheel, and you got the donkey only going in one direction, saves a lot of time, and then you invent a crane, it brings the stuff up high. But the more important question is, I'm standing on top of this dome, and how did Brunelleschi keep this sucker from caving in?
He would have to find a way to keep the bricks in place and support the bed joints of the masonry. The solution? An ingenious bricklaying technique that relied on careful angles, placement, and friction.
Brunelleschi comes up with this invention, if you will, from Rome, which they use decoratively, but we don't know that they use it functionally, of herringbone bricks. You have a short brick here that's sort of bookended by two long bricks, and subsequently you have weight coming down, then weight coming down, and then weight coming across, and then weight coming down, and then weight coming across. The whole point of this is that a herringbone pattern will displace the weight out and down instead of just directly down, where you might have a collapse of your dome.
To solve the opposite problem of bricks bursting outward, Brunelleschi laid a set of chains horizontally around the octagonal circumference of the dome.
They were going to construct these so-called catene, or these horizontal chains that were intended to maintain the hoop stress or the lateral thrust of the dome.
5 chains were to be interlocked at regular intervals to support the dome and serve as invisible buttressing. All this time, Brunelleschi was forced to supervise the project with his co-engineer and rival, Ghiberti. Now, with material for the placement of the chains pouring in, he would seize the opportunity to move Ghiberti out.
In August of 1423, Brunelleschi called in sick. Ghiberti rather reluctantly then begins the direction of the placement of these wooden chains. And as soon as Brunelleschi heard that the process had begun, he miraculously recovers, inspects the quality of Ghiberti's work, and criticizes it publicly, saying they would have to undo everything he had done.
With Ghiberti sufficiently humiliated, Brunelleschi was declared the head of the project for life. On August 30th, 1436, after 16 years of construction, the largest masonry dome in the world was completed. But Brunelleschi's career was far from over. Even before the completion of the Duomo, he had been experimenting with perspective and mathematical proportions. Although his structures appeared simple and straightforward in design, there were spatial games being played with the lines of buildings. And one of Brunelleschi's greatest innovations was a concept that is still a cornerstone of engineering today: single-point perspective. By looking at this 8-sided baptistry and the other buildings surrounding it, Brunelleschi realized if he placed 3-dimensional buildings on a 2-dimensional plane, they would disappear at a finite point, called the vanishing point. This idea that the apparent size of an object would decrease with increasing distance from the eye would transform the entire landscape for artists and architects around the world. allowing the concept of the blueprint to emerge.
What it does in architecture is change the game all the way through Frank Lloyd Wright and to Frank Gehry today. Because architecture is no more just building. It isn't figuring it out in the dirt and saying, hey, if this wall is that long, we got to make the spire that high. Now they can deduce it and put it on paper. It's no longer the builder who's in control, it's the architect.
Before Brunelleschi, most projects were based on approximate models. This would come to an end when Brunelleschi began this practice of what we call paper architecture, and that is clearly indicating what his plans were, and then begins the sort of modern tradition of architecture today.
Brunelleschi's radical new design